Hello dear friends, welcome back on a tutorial from the CAD-CAM from the IK. Today we will see the CAM tutorial and we will see how to create the pocket milling, the flat pocket milling like this one and this pockets, and as well as we will see how to create the drill cycle in order to drill these small holes. Also we will see how to create the drilling operation. I mean the whole milling, not the drilling. For this we will see how to create the whole milling operation. So this is our the part is the prismatic part. Now we are in the modeling environment of the NX. So as usual that in order to initiate our the manufacturing process, we have to go to the CAM environment of Linux. In order to do this, as usual, we will go to the application and from the menu we will select here the manufacturing. So we will be directed to the CAM environment. So and as usual for the beginning we have to specify the part overstock and the 0 point of the over the workpiece. So let's start to do it. So here in the this one in the geometry view you will select here, you will see here the this one and this workpiece. So here we will define our the 0 point. So double click here this icon and you see in advance I already just selected my 0 point on the corner of my the workpiece. You can define the this point or any point as a 0 point of your workpiece. So for the prismatic part, it is better to define the like the corner. So here downward to 0 point and just press OK. Now next step is to define the workpiece and the stock. So double click here the workpiece and here the specify the part. Click this icon and select the workpiece. So part is selected and press OK. You can see here by the pressing this icon display. This is our the part is specified. Now is to specify the blank is the stock value. So here we have the selected this one and as usual we have the several type to specify the blank geometry, starting from the geometry offset, boundary block, boundary cylinder, and so on. In this case, since our the part is the prismatic part, let's select here the boundary block, and here we have to specify the values along the coordinate system that is we want to make the stock. In this case, let's keep the all the values 0 and don't put any values as a stock in the general along the z-axis and so on. So we will just keep the stock value as the same with the workpiece. So just press OK. So this is our stock value and this is our the material that is to be the workpiece to be the machined. So here as usual you can specify the material for the workpiece. By default here is the carbon steel. You can go here and here from the list you can define the material when which you want. So just cancel. Let's keep here the for our the case is the carbon steel and press OK. Now we are the initiated the first settings for our the operation. Now let's start to do the create tool. In order to create the tool, let's for the beginning make some measurements. Go to the analysis here. Here the go to the measure the distance and here the distance and the distance from here to here is the 10 millimeter. So depth of this pocket is 10 millimeter and the here the diameter of this hole, let's select here, this is 6 millimeter. So now and here the diameter of this corner is 20. So now we defined our the parameters, the distances. Now let's create a tool for the pocket. creation for the pocket, for the milling of the pocket. For the pocket creation, we will use the end mill. So and the flat mill. So in this case, we will go here the mill planner, and from the tool subtype, we will select here the mill. This is the end mill. So we will select this one and press OK. Here the our tool is illustrated, but here this is too big for our the pocket. We will here the change the it is the parameters. Let's make it diameter is 10 millimeters. So since here we have the radius the diameter is 20, so it is the okay. You can move it. So this is our the tool, and also you can define here the this length called the flute length. In this case, it is the 50. This yellow one, and this our depth is the 20 millimeter, the 10 millimeters. So not 10. Let me check again. Just a moment. Sorry. Measure the distance. Don't worry. Just distance, and the distance from here to here is the 10. Yes. So since we can also the change this value, the flute length, that's the depth of our the cutting to the 20, for example. So it is okay. It is enough. Will be enough. You can maybe to be safe. Let's make it 30. And also you can define the total length of the tool. In this case, by default is 75. Let's keep it 75. And here the flute number is 2. In this case, it refers to the number of the teeth of the tool. And here the tool material is the high speed steel. Then you can define by yourself by the library, from the library. So let's keep it as a high speed steel. And here you can define the numbers of the tool in the tool set. So let's change all of them is to the one. This is just the tool number one. It represents, and here we can define the it is the shank by the clicking here, or we can again here we can create the holder. In order to create the holder, you can input, you can write the input values for the holder parameters here by the looking to this picture, or you can create it from the library. Go here to the library, and you can create the holder from the retrieve the library. For the first time, let's create the holder by the values, by the putting the here the values. Let's, for example, it depends on the specification, that is the holders available on your the workshop. So let's I will write some a bit of the numbers 20, and let's the length is this length, let's make it let's try to give the 50. So you see the holder is tried start to create it. So the upper diameter, let's make it 40. You see the holder is start to create. This is our the holder. So we can give the higher value for the diameter. So this is our the holder, and we can also give the this value bigger. So, and the corner radius, let's make it 5. This is this one is the corner radius, and the taper angle, let's make it higher. Also let's make it the length is the higher, so we will create the higher. This is the folder, so you can let's okay, let's keep like this. Also we can create here the offset. In this case, by default it is 0. The offset is this value is here is the offset between this tool, the inside of the folder. Let's give it for example 2 millimeter offset. So tool, you see, I will show here, tool will be the here the inside of the holder. So this is our the tool. for the pocket milling. Now we can press OK, and from the here the machine tool view, we can see that this is our tool is created, and we can as usual rename for the proper application. So let's go to the right click and rename, and write this is the end mill, and let's specify it is the diameter was the 10 millimeter. So this is the tool for the this pocket milling. Now let's define the tool in order to create these holes. It is the drilling operation. So we will create the drills for this operation. So in order to do that, let's go home and select here the create tool, and from the type select here the hole making, and here select the STD drill. So, and or you can go here the retrieve tool from the library and go to the drilling, and let's select here the twist drill. So it is just simple drilling operation. So let's select here the OK, and we can just press OK to see the list of the drill tools available in our the library. Here the several twist drills with the, you see the diameter, and since the diameter is here the 6, we have to select the twist drill with the diameter of the 6 millimeters. So go the lower here that this is our tool is a 6 millimeter, and we can illustrate it here by display this one. So this is our tool with the holder itself automatically, and press OK. So just cancel in this case. So you see the twister is illustrated in our the tool list, and let's rename it also. So right click, rename it, and call it as you want. In this case, I will call it as a drill tool with a diameter of the 6. So now we created our tool for this operation, and let's for the beginning just now let's create the other tool for this operation. In this case, we will use this end mill, the same for this pocket milling. No, let's create lower diameter since it is not fits for this dimension. So let's create again the end mill with the lower diameter for this pocket milling, and for this hole making we will use the same tool which we create now for this uh, pocket milling and for this hole making. So let's go to the create tool again, and change the type to the mill planner, and we will use the end mill. So press OK. Let's make it diameter, let's not 3 but 4. So let's keep it 4, and let's keep other values like this, and we can create the holder by the library. So retrieve here the go to the library, retrieve the holder from the library, and just select from the here the milling operation since we are in the milling, and press OK, and just press OK again, and you see here the several the holders which is the exist in the NX library, the small collect, the large collect, and so on. You can just click in the displays to see the your the folder. So let's select this one, and it's OK, and just cancel again. Sorry, the tool is not created. Let's go one more again. So this one, I cancel it. That's why. So let's 4 go to the holder again, and go to the library. Retrieve from the library the milling operation. Press OK. Press OK again. Select the first one. You can display it again. OK, and here press again OK. So that's why it is created now. So let's rename it here. Go to right click, rename. This is also the ant mill. So this is also ant mill. In this case, it is the diameter is the 4 millimeter. So I specified it is diameter. So we create three the tools. Ant mill with the diameter 10 millimeter, the drill, twist drill with the diameter of the 6 millimeter, and ant mill for diameter is 4 millimeter. So in order to obtain this shape. So now we are ready for the operation. So let's go to the create operation. So we will today use the floor and wall operation in order to create the pockets for the beginning. So here we have this one floor and wall, the first one in the type of the mill planner. So selected here the floor and wall. It is selected, and then the location as usual to select the program here. The tool, since we are going to remove the first pocket, we will select that this is the tools which we created in advance. So here we will select the end mill with the diameter 10 millimeter. Here there is a geometry the workpiece, so it means that our system automatically defines the geometry and the blank. So here the method, let's make it finish, and you can define here the name of the program. So by default it is the floor and wall. It is the same as here. So press OK. Now in this menu you have to specify the two main operation, two main you have to define. First one is the cut area. They specify the cut area and flow. That is one. So it is not specified. So go to here. In this case, we have to specify the cut area, the face where we want to make the operation. So in this case, the selection type, let's keep always the face in the cut area. So in this case, we will select, for example, if you want to make the operation with this pocket, so go to the select this face. So select this one and press OK. So the face is selected, cutting area is selected. You see it is illustrating here. We can here the display it, this one, and specify the wall geometry. The specify the wall geometry. You can define the wall geometry of the pocket, the manually or automatically. For example, you can see here for the beginning, let's make it automatically. If you activate this one, and you see it is automatically defined. If you display it, see the wall of the pocket is, you can see here the blue line, blue faces, so it is automatically defined. It is the how to define automatically the wall. In the next one of the pocket, I will show you how to define the wall geometry the manually. Now let's keep it like this. And the next step is to define the tool is already defined. That is the diameter 10 millimeters. So let's go close it. Tool axis, here the axis should be along the Z. So change it. And the method we define it is the finishing, and the cut region, let's keep it floors. And the cut pattern, in the pocket milling, the most used one is the follow part or the follow periphery. So let's see the both of them step by step. Let's start from the follow part, and the most used one is this two one for the pocket milling. It is more efficient one. So here the maximum distance the tool. So here the floor blank thickness by default it's 3, but this is the thickness is was the 10 millimeter, so you have to change it 10. And depth per cut, so depth per cut, let's make it 1. It means that we have the 10 layers. So this is the shape, we will create the 10 layers of the cut. Now we can here the generate for the beginning to see the tool path. So you see the tool path is created with the cutting and non-cutting tool passes, and here this non-cutting passes and approaching, engaging, and cutting in several operations. So, and what we can do again here, the cutting parameters. So if you go to the cutting parameters, that you will see the several options like the cut direction, that is the clean cut or conventional cut. So it is not the important to select which one the method is here, and also with the corners. Then in most cases for the pockets, the pocket milling to keep all these parameters by default, which is the existed. So let's press OK, not change and not change it. Also the non-cutting parameters also they keep what is the system is giving the option. So for example, the engaging is the ramp up on the shape, not change it, and the retract is the same as the engagement. And for example, rapid movement is the clearance movement, that is the clearance to access. This is the red one, so it automatically defines the clearance points and automatically defines rapid movement and engagement, retract movement, and so on. So we can keep these settings as the system gives for us, but you can change by yourself as you want. So now I will keep it here. And the feed and speeds. As usual, we have to specify the speeds and the feeds for our system. We can start to specify the spindle speed. I'd activate in this one, and let's give the spindle speed 1000 RPM, and you can calculate by this icon other the feed rate and surface speed of our system. So here it is the calculated by the clicking this icon and press OK. So we defined our the system as usual. Let's for the beginning define the time analyze the toolpath. So go to the option here, edit display, here the path color, and you see here the toolpath colors represented. The red one is the rapid movement. You can see here, we already mentioned it. It's the rapid movement in the air. This one is the approach. This one is the process. This one and this one is blue. It's not. It is difficult to distinguish. Let's, for example, change this approach angle. Go to this color, and we can change this one. So let's select it green, like the dark green, and press OK. OK. In order to see the result, we have to regenerate it. Now you see, now it is starts to becomes the green. Now let's go again to the toolpath, edit display, path display color. Now is the approach. So this one is approaching. It means that tool will come here in the air and start to approach to the workpiece from the zero from along the z-axis, so to this position. And this is one is the orange is here the engagement. So you see it is the first engagement of the tool with the material. So the first cutting operation starts, and this one is the first cut here, and this one is the main part of the program. So this color is this is the toolpath. This is the cutting operation in this manner. Then is we have this is the tract. This color you say is the retract. It is the retracting of your tool from your the material. And here is the departure. This color, this dash line. After the retract, you see, after the retract, it is the departure. Also, I forgot here the step over. This the green, light green. Is the change of the layer of the tool between the pockets. So change of the layer. It's a decreasing layer. Step over. It's called a step over. So this is the how is the tool path is analyzed. So you can analyze that by yourself. So press OK. Now we can simulate the operation. Go here the verify. Select say the dynamic, and here you can decrease or increase the speed of your animation, and just press the play to see the result. So the pocket is the removing the layer by layer. Every cut layer is the 1 mm as we specified, and it is the finished. You see the no more material is the remained, even if in the corners, since we define it as it is the finishing operation. So we have finished it with the pocket. So press OK and press OK again and go here the program order view, and you see here in the program order we created here the floor wall operation, or we can rename it as a right click and the pocket mailing as you want. Pocket mailing. So this is the first pocket mailing. Now the next step is to create here these holes. It is drilling operation. So we already created our drill with a diameter of 6 mm. Now go to the here the create operation. From the type select here the hole making, and here the select here the not spot drilling. The second one is the drilling operation. So go to the select the drilling operation. From the location keep it as program, and from the tool select here the drill, the twist drill with a diameter of the 6 mm. Is the select the workpiece, and select here the some method, the drill method, and here you can define the name of your operation. By default it is the drilling, so let's keep it like this and press OK. So now here we obtained this menu. So in this case what we have to do is to just specify the holes. In order to specify the holes, here the specify the future geometry, go here this icon, select this one, and just here the select the object feature, just select your the hole where you want to make the drilling. So step by step select the hole. So select this one, you see they selected this one. The order of the selection it's not important, but the order of the selection you will follow your the tool, and how you will select your the holes, the tool will be the moved as you select. So in this case the first drilling will be this hole. In my cases the second drill will be this one, and if I select this one as a short one it will be the short one, or if I select this one the drill will be this one. Let's select this one because it is the closer this one, and select the last one, this one. So stay here in the list. You see the four hole is the selected hole one, hole two, the hole three, and the hole four with the diameter of the 6 mm. Also with the specification of the here the you see with the depths, and here you see the all the parameters, and you can here the change the depths and the values of the depth here by the from the geometry, or you can just click here and user define it, and you can define here the depths as you want. In this case I will not, if you have the several holes here that with the depths you can specify the several depths. In this case the holes depth is same. I will I will just go close this one and keep all the depths is 10 mm. So this is our the whole selection, and just it's enough for us. So press OK, and here if you go here the display, you see that the hole is displayed to be the drilled. And one more thing is here the motion output. So it is the important. You can define that as a motion output at the machine cycle or single move. So if you select the machine cycle, this hole is obtained by the drill cycle, like the G81 is the drill cycle for the in you when you create your the G code. It is it will be obtained either in the G81 is a drill cycle. If you select here the single moves, this holes is obtained just a single moves, like like the G00 and G01 code. So it is better to use the machine cycle in the drilling. So it is the more efficient way to use this kind of drill cycle. So in the tool, it is obviously selected our the twist drill with the diameter 6, and the method is obviously the drilling method, and the cycle is the drill. Only we are making only the drilling, no more. So and here the cutting parameters, let's keep as the default, so it is not important for us. So the system automatically defines the optimal cutting parameters, also the non-cutting parameters as well, for the engagement, for the retracting and so on. So the system automatically defines. However, for the fit weight and speed, we have to give some inputs, and this input is mostly that related to the tool specification. Just by default, I will give the as usual 1000, but when you creating your own program, you have to see the tool specification, that which kind of the tool speed should be given. So let's calculate it and press OK. So now the program is ready for the simulation. That just one more step is to generate our toolpath. So press the generate. So you see the toolpath is generated. So this is the red one is the rapid movement in the air with the G00 code. Here we have the engagement and the tool, that's the drilling and the retracting movement with the blue, and and so on. So let's verify it. So tool is over here. Just play it. Let's see one more again. I heard the restart it, and play again here. So the hole is created with a 6mm tool. So we obtained it. Press OK again, and here you see the drilling is obtained as operation. So we made it now. Next step is to uh, make the pocket of this one. So in this case, we will use the tool which we created, and once here this tool and mill with the diameter 4mm. Also, we will use this tool in order to create this hole. Is the operation is the hole making. It is not the drilling, but it will hole milling operation. So for the beginning, we will create the pocket. So in order to create the pocket, as usual, go to the create operation. As a type, select the mill planner, and here we will see the floor and wall as usual. We have also the floor and wall with IPV to create the pockets, but we will see that this in the next hour the lesson. So now let's only focus for the first method. Just in the as a location, the keep it program. Now change our tool is here the end mill with the diameter 4, the geometry workpiece, the method. Let's make it finish directly, and the name is the floor and wall. Let's make it directly change it pocket pocket to second pocket. Okay, and press OK. So now, as usual, we have to specify the cut area. So go to this icon, and here this one, press OK. So and display it, you see the cut area is specified. Now let's specify the wall geometry, the manual. In the previous pocket, in this one we define it with the automatical. Let's now define it manually. In order to define the manually, select this icon, and here you have to select the walls faces, this one, and step by step select all the walls. So you see the walls is selected, and this one, so all the walls is selected here, you see, and here you see the 4 faces selected, and press OK. So you see now we defined our wall also here, the blue one manually. The tool is the already specified. So tool axis change it to the along the Z positive. So close it. And let's see the here the in the first pocket we have seen the follow part. Now let's select the follow the periphery the method of the cut pattern. So since that this two one, the first one and second one is the most efficient tool pass, the pattern pass is used for the pocket milling. Here the depth is the the measure the depth of the pocket analysis, measure the distance. Distance between this one and this one is 6 millimeter. And here the specify the floor blank is the 6. And let's give the depth per cut is the 1. And we can now read out the program for the first generation. Here select the generate. So this is our the tool path is generated here. You see with the rapid movement engagement and so on, with the cutting, with the retract and so on. We analyze it all the tool passes. So as usual for the pocket, we can keep the cutting parameters and non-cutting moves as the system gives us. So it gives the optimal solution. Now we have to change the feed rates and speed. Let's give it 1000 and calculate it. Now we can go here for the verification and then make some simulation to play it. So to see the operation, so it is the removing the pocket. So we have to be careful with the corners. There is no should be the material remain. So it is the not material remain since our tool is enough to properly locate for the corners. So we finish it our operation. Press OK and OK. Here in the program you see in the program order we have this pocket miller and the drilling and the pocket is the second pocket. So now let's define the last operation for today is here the not the drilling for this hole but milling. It is the called pocket milling. So it is the not drilling. In this case we will use the here the not drill tool but the mill tool with the flat mill tool with the diameter 4 which we created in advance. So now we will create just operation. Go here the home, create operation. The whole milling is inside of the type of the mill planner. It is located here. You see the whole milling. So here the select the whole milling, and here the location as usual the program. Here the select the end mill with a diameter 4 millimeter, the workpiece, and let's make it directly finishing operation. And let's select the name as the default here the whole milling. So that's okay. And in this menu that usually you have to specify the hole where you want to create the milling operation. So specify the future geometry, select the icon here, and here to select this hole. But you see it is selected here the hole, which is the larger the here the hole. In this case, in order to change the values, go here the diameter is 25, and go here the this one and the user define it and make it the diameter of the hole was I think the 10. Let's see it. Yes, you see it change it to the 10. And let's define the depths also here. User define it and define the depth of the hole is the 20. Like we showed from this one. So you see the 20. So we can define our, so we defined our the hole parameters. So here you see it is defined here the 10 and the depth is 20. Now we can hear we defined our the hole, so press OK, and you can see I display here, this is our hole to be the millet, so it is the whole milling operation. Also you can define the cut pattern. You can define the two cut pattern as helical, spiral, the circular, helical, spiral, and so on. So let's go with the helical for the first time. And here you can keep the cut patterns, cut parameters, and non-cutting moves by the system default, so it gives the optimal solution for us. So let's keep this one and give the feed weights here 1000. Let's and calculate it. Press OK. So now let's generate the toolpath. So here press the generate. You see the toolpath is generated for the whole making, and we can verify our toolpath. So here we can locate our in the proper position. We can decrease the animation speed and just press play. You see, it is the whole making operation is obtained. So press OK and press OK again. See in the part program order, you obtained 4 operation. The first pocket milling, the drilling, the 6 mm, the second pocket, and the whole making operation. The 4 operation in order to do this operation. And simultaneously, we can step by step simulate all of the program. Just press the first one and press the control and select all the program step by step. You see the all is selected and the toolpath is all is generated here, and we can go here to verify the toolpath icon, and here we can make some settings so the dynamic and make the speed of animation like the two, and just press the play to see the all our operation is the first pocket is the layer by layer is obtaining 1 mm with the tool is the 10 mm diameter, and the next is the drilling operation with the 6 mm, and the third one is the again pocket, second pocket with the tool is 4 mm. Now is the last one is the same tool, the flat tool. The end mill is the used for the hole making operation. So here press OK. So we have finished with our operation. In order to generate the G-code, as usual, in the selected form here, you will go here the post processor as usual. Select from the list of the post processor which you have. So in this case, let's select the 3-axis. You will define the measurement unit. So in the settings, so it is the matrix, and press OK, and just press OK, press OK again, and here you will be generated your the G code. So here I will go to the up here. It starts from the line with the 10, with the these codes and so on. This is the old operation. So in order to obtain this program, so let's close this one. So what is this program? So this is the lesson for today. We in this case learned how to obtain the pocket milling as well as the drilling, and how to create the hole with the milling operation and select the proper tools for these operations. And we analyzed how to the toolpath is obtained in this case. So thank you very much for the attendance, and wait other the tutorials from the NX in the upcoming days.